Now it's your chance to try reviewing these problems for fraction addition and subtraction. Whenever you're ready, you can continue the video. Now looking at part A, we have the denominator of 8 and 20, and again we can use this prime factorization method to find the least common denominator. So we have 8 and 20, and 8 we already know is 2 cubed. 20 we can break it to be 4 times 5. 4 again is 2 times 2. So that really is a result of 2 squared times 5 over here. And now if I want to find the least common denominator, I have a base factor of 2 and a base factor of 5. And now I want to look at the highest degree of these base factors in terms of the factorization we have. And for 8 we have 2 cubed, and 20 we have 2 squared, so the highest degree of 2 would be 2 cubed. And 5 we only have it once, so it's just 5. And as a result, 2 cubed times 5 will be 8 times 5, or 40. And that's going to be the least common denominator. So that means I want to have 40 here and 40 over here. And to go from 8 to 40, I have to multiply by 5. So I have to multiply 5 on both sides of the fraction. 3 times 5 gives me 15. And then from 20 to 40, I have to multiply by 2 on both sides. And that gives me 14 over 40. Once we have the common denominator, we can combine the numerators. 15 plus 14 is 29. So we get 29 over 40 as a result. Now looking at part B, we have 30 and 50 as a result. And again, we can think about how we factor out 30. 30 is 2 times 3 times 5. And then for 50, 50 is 5 times 10 over here, which is going to be 5 times 5 times 2. And you can draw the prime factoring tree as well, but I'm just going to write out the result. And based on this, we know the least common denominator has the base factor of 2, 3, and 5. And looking at both factorization, we have the highest degree of 2 in each individual factorization. It's just 2 to the 1, and 3, we only have it once, so 3 to the 1, and 5 will be raised to the second degree, because we have that 5 squared in the factorization of 50. And altogether, we would have 2 times 3 times 5 squared over here, which is equal to 150. And that tells me if I want to compare the default or the original denominator was 150, to go from 30 to 150, I need to multiply by 5. You can also see this by looking at the factorization for 30 versus the least common denominator. The difference between these two factorization is that 5 is getting squared. So we have an extra factor of 5 in the common denominator. That's a quick way for us to determine what to multiply on both sides as well. So we would get 35 on top and 150 on the bottom. Then for the second factor, from 50 to 150, again, if you compare the factorization between 50 and our LCD, we have an extra factor of 3. So that means I need to multiply 3 on both sides of the second fraction. And with this, we can say the second fraction has 150 on the denominator and 33 on top. So combining it gives us 68 over 150. And then we notice they're both even numbers. When they're even numbers, that means they contain a factor of 2. So I'm going to go ahead and divide by 2 on both sides. As a result, I will have 34 over 75. And they don't share any common factors anymore. If you're ever unsure, you can always do a prime factorization for both and check whether they share anything common. And now for the next problem, for part C, we have 16 and 6 as the denominators we get over here. And you can again try the prime factorization and see what you get. In particular, for 16, this is equal to 2 to the 4th, and 6 is equal to 2 times 3. And therefore, for the least common denominator, we should have 2 to the 4th, because that's the highest degree of 2 we have among these two. and multiply by 3. That's the highest degree of 3 we have among the two. So altogether, we would have 2 to the 4th, which is 16, times 3 will be 48. And I want to have 48 in the denominator. Again, comparing the factorization between 16 and the LCD, I have an extra factor of 3. So that means I need to multiply 3 on both sides. And 13 times 3 is 39. Now comparing what we have for the factorization of 6 versus the final result, I have an additional power of 2 to the 3. So that means 2 to the 3rd is going to be 8. You can also get the same result if you're familiar with a multiplication table. You get 6 times 8 is 48. So 5 times 8 on top is going to give us 40 on the numerator once we find the equivalent fraction. And 39 minus 40 becomes negative 1 over 48. 1 does not have any other factors, so we don't have to worry about any factorization or any simplification from here. Lastly, for part D, we have a minus negative scenario again, so we can go ahead and write the minus negative to be a plus positive 3 over 20. Then again, we want to look at the denominators being 6 and 20. So 6 is equal to 2 times 3, 20 equals 4 times 5, and we did it in the first part, which is 2 squared times 5. That tells me the LCD is going to be 2 squared, because that's the highest degree of 2. That was in factorization, times 3, that showed up once, times 5, that showed up once. And altogether, we have 4 times 3, which is 12. 12 times 5 is going to be 60. So that tells me I would have negative, and I want to have 60 on the bottom. To get 60, I have to multiply 6 by 10, and I have to do that to the top as well. So I get 50. Plus, then for the 60 on the denominator, I need to multiply 3 by 20. To get 60 in the denominator, that means I also need to do that to top, and that would give me a 9 over here. Now we have a negative 50 over 60 plus 9 over 60, and that should be a negative result. And if it helps, you can also just put the negative in the numerator over here, and if that helps you keep track of the values we get, we would really have negative 50 plus 9 all over 60. Which is equal to negative 41 over 60. And 41 and 60 don't share any common factor, so we can just go ahead and stop here.